Hi, hello everyone.
Hello.
Hey,
Who all have we got on tonight? Let's introduce ourselves.
All right, I can go first. My name is Jamal. I am a I'm a person. I don't know. I do Python. I do stuff. And hey, I'm happy to be here to learn some more about JavaScript.
I'm Chris. I'm a .NET developer mostly. ASP.NET MVC is my stack really. Honestly, I'm so-so with JavaScript. I know enough to get myself in trouble.
I'm Clayton. I am a Ruby developer, and which means that I have to use JavaScript more than I would like. I don't love it, which is why I wanted to read this book. I'm also the one responsible for our slides tonight. I apologize in advance. For some reason, they look fine in development, but when you actually make the slideshow, they're broken. I won't use this laptop to make slides again.
It's a unique presentation. We'll just with a unique background. Like the presentation's awesome. It's just the background that's unique.
All right. Yes. So I apologize in advance for the way the slides look. So,
I think it's pretty cool that we have people from different languages here. None of them JavaScript, but looking to learn some.
Yeah. Well, I mean, the JavaScript people already know all this, right?
I assume so.
I'd hope so.
I guess we could start. I mean, so I guess we could start with tonight. We're covering book 1 of You Don't Know JS, which is by hold on, who is the author of You Don't Know JS? I know the name. Kyle Simpson, who is actually, I found out the other day, from Oklahoma, which is interesting because I am also from Oklahoma. And the first book is called Up and Going, which is kind of an introduction to programming concepts and also to the JavaScript language and the basic format of the rest of the book series, which is great. If you missed this one and you want to jump on board later, you can get away. I think you could probably get away with watching this and still be just fine for the rest of the stuff we're going to cover. Would everyone agree with that?
I will agree with you. I have not read the first chapter.
Okay. Well, then let's...
I have to agree with you. This is my first time here or in the channel.
Well, welcome. So the preface, it says, here we address head-on the tendency of JavaScript developers to learn just enough to get by without ever forcing themselves to learn exactly how and why the language behaves the way it does. Furthermore, we eschew the common advice to retreat when the road gets tough. So a lot of us have heard of books like JavaScript, The Good Parts, which I know is a really popular book in the JavaScript community because a lot of JavaScript is considered not the good part. We're going to get some feedback. And this book is specifically setting itself up to be a reaction against that, to say, like, no, if you're going to be doing JavaScript, you need to understand how it works. So, hey, Christopher, I think we're getting some feedback from you, buddy.
Okay, sorry about that.
It's all right. So we'll start on chapter 1. It's just an intro to programming. You know, this is all going to be pretty straightforward to us guys as developers already. Statements. JavaScript has statements. A equals, B times 2. Statements are made up of one or more expressions. You have literals like 2. You have variables like b. You have arithmetic, b times 2. And you have assignments, a equals b times 2. This is all straightforward to us, but they're covering the introduction to programming in general in this chapter, so some people are going to need that. JavaScript is often referred to as an interpreted language. It's actually compiled just at runtime. and this is the case with most languages nowadays. I know Ruby's the same way. Technically, Ruby's compiled at runtime, but it has an interpreter. The MRI, I mean, Ruby MRI is called Matt's Ruby interpreter. One of the great things about JavaScript is it has a console built into every web browser, every modern web browser. So for most of us, when we first get started on a language, it has like a REPL where you like you fire up the REPL and you can like hack out some. I don't know, does Java have a REPL? Some of the more languages that require more setup might not have REPLs, but I know Ruby does, Elm does. A lot of the languages I've played around in all have it. Does Python have REPLs?
Yep.
Yeah. So
yeah, you can just type Python.
Yeah,
type
yeah.
Python the command line.
Fired. What about .NET? Do they have REPLs in .NET? You are muted, sir.
I believe so, but I'm not sure what the equivalent is exactly.
So a REPL would be like, it's a little like thing you can write one line of code at a time in, and it'll spit back out you the return, and you can just kind of play around with code in it. JavaScript, if you hit, at least in Chrome and Firefox, if you hit Control-Shift-I inside of a browser, it'll bring up the console and let you can start just typing JavaScript in the console, and you type a line and it'll spit back the next line at you of what the return of that function or whatever would be. So that's a great removal of a barrier to entry for a lot of people, because for a lot of people you have to get the language installed and you have to learn how to compile it or whatever. And for newbies, just being able to, everyone has access to a web browser, or everyone that's going to be coding. So that's super great. Input and output. For output, in console.log stuff, or you can do alert hi. If you run the alert function in JavaScript from the console, it'll actually, because you're actually interacting with your browser, it'll actually fire off an alert box. So if you're watching this video, you can actually hit Control-Shift-I and then type in alert hi, and you'll get an alert box fired up. Input, you can if you want to get a prompt to save a response to a variable. If you want to get a prompt box to fire off, you hit like age equals prompt, and then what question you want it to be, and whatever they respond with, that will set to the age variable. So that's how you do interaction with the outside world from that console, which is actually more than a lot of REPLs can do. So JavaScript's basic operators, you have the assignment operator, you have math, compound assignment, which is plus equals, minus equals, increment and decrement. Plus plus is to increment by 1. It's supposed to be minus minus there. It looks like an extra long line, but it's minus minus. Object property access, which is just, this dot that. Equality. So equality is weird in JavaScript. You have a lot of languages have equal, equal, and equal, equal, equal. It means some weird things in JavaScript, and that's a lot of what the book talks about, is how JavaScript deals with what's called coercion when you do equality checks. And comparison, and then of course the logical operators and pipe means or. So values and types in JavaScript. I am a string is a string. I am also a string is a string. They both mean the same thing. You can use double quotes or singles. 42 is an integer, true is a boolean, false is a boolean. I'm sorry I'm moving so fast, but this is all pretty, introductory stuff. Conversion, type conversion. Var A equals 42, to convert it to a number, you can call number A, and it'll return a number 42. And then, go ahead.
Real quick, going back to var, is var just saying make a variable, or is it actually a type?
So var is saying make a variable that I don't want to be a global variable.
Okay, so it's like it's scoping it.
Yes. So we'll get to that in a little bit later on in the chapter. It talks about how easy it is in just regular JavaScript to accidentally create global variables. It's super dangerous. So
it's a lot easier than it is in .NET.
Huh?
That's a lot easier than it is in .NET. I'd have to call an entire sub-method of toString or toInt or cast as.
Yeah, you want it to be hard to define global variables because global variables are dangerous, at least in languages like JavaScript. And so the most recent version of JavaScript ES6 makes it where if you call, there's something, we'll talk about it in a little bit, there's something you can do to make it where it won't let you accidentally define global variables like that. But if you define a variable without the var in front of it, it's automatically considered a global variable, which is crazy. But
no matter where it's defined, even if it's in a function or some other kind of block?
If you, well, you could, so ES6 has let, and let is scoped to a block.
Okay.
And var is scoped lexically, so it will inherit from like wherever it's defined on down through the functions.
Okay.
But yeah, anything just like if you just say A equals 42 semicolon, A is global in regular old JavaScript. To my understanding.
Hey, that's good to know.
Yes, very good to know. So JavaScript has this thing called implicit coercion. So string 42 equals number 42 is true, just like 42 equals 42. JavaScript will try to, if you call equal with just the two equals, it will try to coerce them to make them match.
Does JavaScript have an overloaded equality? Like, is single equals only for assignment, or does it do?
Single equals is for assignment. If you look back here under where it says equality, single equals is for assignment. Double equals and not equals is for checking equality without or with coercion. Triple equals and bang equals is for checking equality without coercion. Unfortunately, your comparison operators, your greater than, less than, greater than, equal, less than equal, they only have that available option because it wouldn't make sense for less than equal and then less than equal. So all of those do the implicit coercions. So when you're doing your comparisons, you need to be aware that your stuff will be implicitly coerced.
Okay. Did they talk at all about style and like, is it preferred to use one over the other, or?
So that's the problem with JavaScript is there's not a good style guide for JavaScript. There's not an agreed upon style guide for JavaScript. And so this book makes the argument that implicit coercion exists for a reason. You should learn the rules and learn to take advantage of them. A lot of books think that's crazy and that you should always use the triple equal and the bang equal in any case where it makes sense to do so. Because you can't expect your people to know those rules that are reading your code. So but this book pushes back against that. So we have code comments. This is a single line comment. Single line comments, just like in any other language, it's everything after the beginning of the comment. So the // is the beginning of a single line comment. Multi-line comment is the / star, and then everything between the star and two stars is a multi-line comment. And then multi-line comments, only what is between. You can have code between them. So you can comment out code with the multi-line comment. and it will read. So if you do like var a equals 40, and then begin the comment 42 plus 5, close the comment 47, it'll set it to 47. See what I'm saying? Variables and constants. Variables are defined lowercase with, actually, I forgot to mention this, it's camel case. So begins with lowercase, and then it does, how do you define camel case for people who don't know what it is? The first letter is lowercase, and then the first letter of every word attached to the end of it is capitalized. Would be how I would define camel case. Yeah. So constants. In old JavaScript, constants are a convention. They do not actually exist as a part of the language. So var all caps tax underscore all caps rate would be considered a constant, but it's only a convention. It's not. It doesn't behave any differently than any other variable.
Okay.
Now, since ES6, which is not supported yet in most browsers, though I'm not, or at least parts of ES6 are not supported in. There are parts of ES6 that are not supported in any browser, and there's some parts of ES6 that may be supported in some browsers. But if you use const instead of var, it will make it a constant, and it will act like a constant. So it will like not want you to change, not let you want to change it and stuff like that. So blocks in JavaScript. So I'm used to blocks. So blocks are places where you put logic that you're passing to that are associated with a function.
Mm-hmm.
They're encapsulated by the curly braces. So an if condition in this case would be like if something inside of these parentheses, then everything inside of the curly braces.
Yep, and I think most languages have this concept. They may not use the curly braces, like Ruby uses the keyword in the end, or Python uses indentation, like C# or Java uses curly braces.
So the concept of a block is different in Ruby than the concept of a block in JavaScript. In this case, the if conditional. So in Ruby, an if this, if do something, else do something. The do something is not block necessarily in Ruby. A block is something that you pass with an argument.
Right. Yeah. Ruby's kind of a special case there, but yeah.
Yeah. Conditionals. Var a equals 42. B equals the ultimate answer to the ultimate question. If a equals 42, console.log b. That's how you would structure conditional. Console.log is their way of doing puts or print or whatever inside of the console REPL, at least in this book. We got more conditionals. This is how they do if-else. Seems pretty reasonable to me.
So the convention is to start the curly brace on the same line as the if or the else?
That is how it's done all throughout this book, yes. And
Okay.
I have seen it in other places done that way as well.
Okay.
Loops. They have a while loop. So var equals 0, while years is less than whatever that number is, console.log, and then years plus equal 1. And then that's how to do a basic while loop. Pretty standard. Makes sense.
You see some type coercion going on there too, because years is not having to be converted to a string to get added to a string.
Right. You're right. That is correct. You're seeing some type coercion going on there. That is how they do interpolation in JavaScript, best as I can tell. There is, I think, interpolation being introduced and he has 6. But right now, I think that's how it's done in the language.
Okay.
And I think that may get talked about later in the book. So here's a do block, a do while. The only difference between a while and a do while is a do while will always run the block at least once.
Okay. And is cycles being initialized to 0 automatically? Or is that just that there's an implicit?
No, I just said that. Yeah, I just was writing an example of a do while. Yeah.
Okay.
Yeah. Sorry, no, cycles is not being, cycles you would assume would already have been defined.
Okay.
Here is the for loop, which is incredibly common in JavaScript code. So in this case, you're defining var I equals 0, I is less than or equal to 9, then I plus plus, and then console.log I. So it will print 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
And just real quick, what are those 3 different segments in that for loop definition?
So it's the variable that will be iterated over, the condition that will close the loop, and what you do to the variable to get to that condition.
Okay.
This is pretty standard. Like if I want it to run this many times, this would be how I would define the for loop.
It's the same thing in C#.
Yeah. So functions, function print amount. Print amount would be the name of the function. And then it takes a block, and I'm assuming, so you don't have to have amount defined. You could, for the purposes of this function, you can, so var amount equals 99.99, print amount, because you defined amount before you, because you've defined amount before you ran print amount, it will, amount will get passed into the function automatically because of lexical scope in JavaScript.
Is that a closure, like just like that? Because the amount's not being passed in. Like if you pass that around, that function around later on, would it still point to the value of amount? How does that work?
No,
I'm confused.
Well, that's a whole chapter in the book.
Oh, okay, never mind. I'm getting ahead.
We're getting ahead. There's a whole chapter in the book, but for the purposes of this, you can define a function using amount, and as long as you've defined amount before you run the function, it should be fine. And then amount equals 99.9, you do print amount, and then you do amount times equal to, and run print amount again, and it'll give you a different answer. That works.
Oh, wow.
Yep.
That makes my brain hurt.
Yeah. So all of that, exactly as that's written, is valid JavaScript code, and what you would get in your returns. The functions can take arguments. So function print amount takes an amount, and then you console.log amount to fix 2, and then you can have format amount. We'll just return $ plus amount to fix 2, and so we'll define our amount, and then we run our print amount and pass it our amount times 2, and then we do amount equals format amount and log it, and it should have the $ in front of it there at the end. Sorry, that slide is a liar at the last line. There should be a $ in front of 99.99.
So it's probably discussed later if you have two, like how scoping works as far as like you pass in a variable with a name and then it's also defined somewhere else.
Yes, there is a whole chapter on scope.
All right, then I'll stop asking about it.
Okay. Right now we're just introducing the features of the language.
Right.
We have a little bit on scope today. Variables defined in functions belong to that function. They go into scope when they're defined and out of scope when the function completes. Then there is nested scope. Functions defined inside of other functions inherit the variables of the parent. And so variables defined in the top layer, all of the functions can inherit those variables. So that's why this works, because variable var amount is defined in the top layer, and then, oh, well, actually, it would have been this one. Var amount is defined in the top layer, and then print amount is called, and so it inherits the amount.
Okay, so it's almost it's borrowing some functional stuff there, right? I mean, like it's at least favoring functions over procedural scripting. Or am I reading too much into that?
So my experience with JavaScript is that the more you try to write functional, try to do everything in functions, the better. But it's not. It's not a purely functional. The language is totally fine with procedural. So here, let's give you an example of how the scope works.
Perfect.
We have function outer. Inside of function outer, we define a variable of a and set it to 1. And then inside of function outer, we define function inner. And it has a variable of b and set it to 2. And then it can console.log a plus b, because a is defined in the parent, the child has access to a. But if we call, so that happens when we call inner. And then so if we do console.log a, we have access to it. But because we're inside of the outer function, when we call console.log b, it explodes and throws a reference error, b is not defined. So the parent does not inherit from the child inherits from the parent.
Okay, that makes sense.
Mm-hmm. Top level variables, var a equals 2, it inherits from the top level. Chapter 2 into JavaScript. So this is that was all assuming that was all just to introduce you to like programming concepts like functions and stuff. We're actually getting into more JavaScript specific-y stuff here. Chapter 1 covered concepts that are generalizable. Chapter 2 introduces things that are specific to JavaScript. As you can see, a lot of the stuff in the first chapter I thought was pretty specific to JavaScript, but at least the ideas of functions and things are in all these languages. Apparently I left a pipe on the end of that by accident. So we have values and types. In JavaScript, string. JavaScript has numbers, it has booleans, it has null and undefined, it has, which we will get into. It has objects. Its objects are key value pairs, groups of key value pairs. So like you could have key value, comma, key 1 or key 2, some other value, comma, whatever. It's like in Ruby it would be like a hash, except it's not, because it does other things too.
Okay, that actually explains JSON a little bit more than, because that's JavaScript object notation, right?
Yes, I think so. Okay. So it has, since ES6 it has symbols, but we're not going to cover them in detail in this chapter. We'll get into them later.
Okay.
So an object in JavaScript. So object equals A, hello world, B, 42, C, true. And then we say, and then they can be treated like what I would be used to calling a hash call or a dot method. So object.a is hello world. So is object bracket string A. And then both of those all of those work to call the object.
It doesn't care which way you call it.
Nope.
Okay.
So here we go. Var object equals A, hello world, B42. Now if we say var B equals string A, then object B equals hello world. Object string B equals 42.
Okay. And why is the difference there?
So because we set B, the variable B, to equal to A. And then we actually called, what the first one of these two is actually saying object string A. You see what I'm saying?
Yeah, because one of them has quotes around it and the other one doesn't.
Yes.
Okay.
So that's how that works. And then here's where arrays get introduced. You have an array. It's just a collection of, it's a list sorted by, or indexed. So you call, count from 0 to call the items in the array. An array is an object in JavaScript. I mean, anyone with experience with arrays, this will all seem very normal.
Okay, what if you index outside of the range of the array?
It will say...
Did you get an error?
Remember.
Or
Hang
does
on.
it just... Okay.
Control-Shift-I.
He's going to bring it up.
Let's see. Equals. The nice thing about this is we can literally bring up a REPL right here. So I'll do array equals, it's an array with 1, 2, and 3 in it. And then if I say R, and we'll call the index 5 on it, and it says
3, sir.
Undefined.
Undefined. Okay.
So it's not nil, it's not null, it's undefined.
Which is the separate value from null in JavaScript.
Yeah, they have null and they have undefined. And they also have not a number.
Okay.
We'll get to that one too. Yes. So JavaScript's functions. Function foo return 42. You can define dot methods on functions, which people have told me Python does this too, and it's not that crazy, but I disagree. It's insane. So functions, if you call foo, you get 42. If you call foo.bar, you get hello world.
How do you get hello world?
If you say foo.bar equals hello world, and you call foo.bar, you get hello world.
So function's an object.
Yes.
Okay.
The type of function is, functions are, yes, you can, no. You can define dot methods on functions.
Okay.
I won't say that it's an object. It's something that acts partially like a function if you're looking at a strongly functional language, but it also acts partially like an object.
So why would you need an object if you can define a dot method on a function, or vice versa?
I don't know enough about the language to. Well, so I think that it. I don't know. I mean, okay. I don't know. That's
fine.
We're learning.
Yeah. Okay. I'm just curious.
I'm sure we'll get some JavaScript people who watch this and are like, "You guys."
I don't expect you to explain all of JavaScript to me. I'm curious.
So we have some built-in type methods.
Hey, rounded pi day.
Oh yeah, I didn't even think of that. I wrote this last week. I didn't even think of that. We have dot length. We have dot to uppercase, and we have dot to fixed. To fixed will round to the argument passed to it. So I defined 3.14159, and then I ran b.toFixed with an argument of 4, and it rounded it to 3.1416.
I see. What's the significance of the word fixed here?
I guess it just fixes the rounding of the number.
Okay. It's not like a numeric type or something.
I
Sorry, too many questions. Go ahead.
will learn. We're all newbies at this. Then we get into some coercion. Var A equals 42. Var B equals A times 1. A equals 42 as a string. B equals 42 as a number.
Okay.
We have Truthy and Falsy. Some of the falsy values in JavaScript are an empty string, 0, -0, and not a number, null, undefined, and false are all falsy. Everything else is true.
0 is okay. Well, I'm just
So
curious.
that's actually not that uncommon in programming. There are a lot of languages where 0 is falsy.
I'm not going to comment on -0, but
Yeah, I have it.
would it coerce a string of 0 into 0 and therefore be falsy, or would it consider it truthy because it's a string?
It's not an empty string.
So it's truthy.
So it's truthy, I assume.
Okay.
I don't know. Control-Shift-I.
Yeah, let's give it a try.
If string 0 console.log I it might help if I actually put it in. Stop trying to write it in Ruby. Let's see what it gives me. Yeah, it spit out high. So yes, 0 is a string. It does not coerce when it's doing a truth check. That was a good question. I didn't even think to ask that. Equality and coercion. Var A equals 42. Var B equals the number 42. A equals B is true, but A equals B is false. We mentioned that earlier. Here we get some crazy pants coercion. Var A, an array of 1, 2, 3, and var B, an exact same array, and then var C of the string 1, 2, 3. A equals C is true. B equals C is true. A equals B is false.
Because they're different objects?
I have no idea.
Not at all.
All I can think is that
crazy.
it is making two different array objects and it's comparing them by memory location, but it's...
I don't know, but it's nuts. And I tried it. Like, I tried it, and that is what you get.
Why would... But...
I know. I want a JavaScript person to come on here and explain that to me. Yeah. Apparently, when you do any kind of equality checking on an array, it turns it into a string. But why it doesn't turn them both into a string, I have no idea.
Oh.
That's
yeah. But why?
Yeah. I have no idea. I mean, I'm happy to somebody to come on and say, you're insane, you just made this up, this isn't the truth. But the best I could tell, that is the case in JavaScript.
Okay.
Yeah.
I can see
it's not going to do it, but yeah, this would be where your head explodes. Because I turned off animations. Yeah, but that was going to be the guy's head exploding. Yes. Inequality and coercion. So we talked about this a little bit earlier. Because there is not a strong equality, I guess strong equality is what I call it, I don't know. Because you don't have strong equality and coercion in like greater than and less than checks, it's always going to do the conversions. So A is the number 41, 42, and 43 are strings for B and C. A is greater than B and B is greater than C are all going to work. But if you do A equals 42, the number, and B equals the word foo, greater than, less than, and equal are all going to be false. So that makes sense.
And okay, so that's a shortcut. If you're getting values from the user, you want to compare it. It's a number. I kind of get why they did that. I think it. I have to imagine that it's causing some sort of weirdness, but I could be totally wrong because I haven't ever used a language that does that.
Yeah. We do have reserved words. For, if, in, while, null, true, false. Those are reserved. You can't use them as variables. They'll also act weird if you try to set them as keys and objects. I ran into this the other day on a quiz. Okay, so hoisting. This is a concept that we'll get into a lot deeper later, but we're getting close to the end of the slide. But this is a concept in JavaScript that's very important. Functions declared inside of a scope are hoisted to the top of that scope. So if we say var a equals 42 and then call foo, if we can define foo after we call it, and it'll hoist the function declaration up to the top with the variable declarations.
Okay, so Python doesn't do this. You have to define, unless you're inside an object, if you just start defining functions, you have to define the function before you can call it.
Yeah. I mean, this makes sense, and I guess this is not a thing that Ruby lets you do. But
yeah, same with Python.
Yeah.
I think C# lets you do this, but I could be wrong, because it's all objects, so it's not quite the same.
Well, you have to actually declare before you can call, or you actually have to declare and instantiate before you can call.
But can you instantiate at the top of a script and then define the object you're instantiating in C#? I don't remember.
Yeah, as long as the instantiation comes before the call.
Okay.
If that makes any sense. As long as you define whatever it is and instantiate it before you call it. Because the compiler goes line by line by line by line. And if it doesn't find a definition before you get to A equals B, it has no idea what B is.
So there's no hoisting there either.
So that's not how compiling works in JavaScript, and there's a whole section on hoisting explains how compiling works in JavaScript and why this does work.
So does it run almost like a method missing in JavaScript, where if it finds something it doesn't know what it is, it'll search the rest of the file for it and look at it?
Yes, there's definitely some looking around inside of like scope and looking in parent scoping and things like that going on in this language. Yes, and there's definitely some forms of inheritance, but they're not like inheritance in Ruby. Don't pretend that class inheritance needs to go completely out the window. This is a whole set of different kind of inheritance.
Okay.
Nested scoping. When you declare a variable, it is available anywhere in that scope, as well as any lower or inner scopes. We mentioned that a little bit earlier. This is for var variables. Anything defined without the var is available globally. So here's an example of nested scoping that gets a little fancy. You have function foo, var a equals 1 is defined inside the function. Then you got function bar, b equals 2 is defined inside that function. And then you have baz, c equals 3, and then you do console.log abc. That works fine. And then baz can console log a and b because it has those two available, and bar can console log a because it has those available.
That makes sense.
Yeah. Here's where I mentioned this earlier, accidental global values. Variables without a var automatically declare globally, so even if you define it inside of a function, oops, there it is. So if you say a equals 1 inside of a function foo, and then you call a outside of that function, it's still going to exist.
So if you forget your var inside a function, you could potentially stomp out a global variable outside of the function.
Oh, yes. Oh, yes.
And you won't even know what function did it. It's just
Oh, yes.
somewhere in your code.
Exactly.
Ugh. Okay.
That's kind of terrifying.
Yes,
That is.
Which is why we will be using use strict every chance we get, which is something that solves that problem for us. Here's switch statements. So how many of you have worked in a language before where the case statements have fall through?
Where the case statements have what?
Fall through.
Oh, like a default value?
No, they fall through.
So if it's
they like trickle down.
Yeah.
A, B, C, D.
Oh, without the break.
Yes.
Okay, yeah.
That's new to me. So I'm used to, if you match, then the case breaks automatically and it just returns the value that matched first. And this one, it does switch A. So we pass in, so we're checking A, and if A is 2, then it just falls through and runs and keeps falling through until it finds some logic. So 2 and 3, if A is 2 or 3, it'll do the same thing. And then if we do case 1 billion, it does something else. And then we can define default at the bottom. And default is just if none of the others hit, then do default.
I think that's a C thing that's kind of propagated
Yes,
in languages.
the fall through thing is the C thing. I hadn't seen it until I looked at this book, and then I immediately, like a day or two later, was looking at some C code and saw it happen, and I was like, oh, that's what that is. Ternary operators are a thing. They're pretty straightforward. They're simple if-else. So A equals 42. If A is greater than 41, then B becomes hello, else it becomes goodbye. Okay, so there's now, in some of the more recent versions of JavaScript, we have something called use strict. If you just put the string use strict followed by a semicolon somewhere in your file, everywhere that is lexically scoped to that statement will no longer will use a bunch of set of rules that make JavaScript much more sane. For example, it will not let you accidentally define global variables. That's like the best thing that it does. But there's several other features with use strict as well. But ideally, you do not want to be doing use strict on a per function basis. You want to either define it at the top level of the file and make it file wide, or not use it at all. That's how the book recommends. Because you don't want to say like this function is going to use strict, but these other 3 functions might accidentally define global variables. You either want your file to have that ability or not. Functions as variables, which seems pretty normal. You just assign some function to a variable. That's pretty normal. This is a cool, kind of an interesting thing in JavaScript. You have something called immediately invoked function expressions, or IFEs. Typically, you have to call a function to run it, but IFEs, by the way they are defined, they are run immediately. So this is an example of an IFE. So function IFE, do stuff here. The IFE that I gave it the name there, that's just a convention. You don't actually have to call it IFE. It's actually how the function is written, not the fact that it has IFE that makes it an IFE.
That's actually kind of like Closure, where you put the parens around it to execute the function.
Immediately?
Yeah.
Yeah. So var x equals function IFE return 42. So then x is now 42.
That's kind of interesting.
Yeah. The function isn't assigned to the variable. It's what the function returns that is assigned to the variable in this case.
I'm trying to think of a case where you would want to do that.
Apparently, it gets used a lot in JavaScript.
Okay.
I think I might have something to do with, like, maybe you have some function that you want to run in a continuous loop because it's monitoring something or something on the DOM. I mean, I'm just guessing. But that might be a case where, like, you want the function to fire off as soon as it's defined and start monitoring or running a loop or something that says, like, on click, do this, you know, that kind of thing.
Mm-hmm.
We do have closures. Closures are a way to remember a function's variables even after it's finished running. So here's a makeAdder function with a closure. So we have a makeAdder that takes an argument of x, and we have a function add that takes an argument of y, and it returns x plus y. And then the makeAdder returns add. So var plus 1 equals makeAdder 1, var plus 10 equals makeAdder 10, and then plus 1 with an argument of 3 will return 4, plus 1 with an argument of 41 will return 42, plus 10 with an argument of 13 will return 23.
So if, with that scoping thing that we saw earlier, if the variable that was, because you're scoping it into the function, then even if it changes, it's still going to be lexically enclosed in the function. Okay, yeah, that makes sense. That looks a lot like a Python closure.
Language has modules. So this is an example of this is like a common structure of a module in this language. We'd have like a user module, which is function user. It has so one of the things you can do in JavaScript is you can define variables without assigning them. So you have a username variable and a password variable that have not yet been assigned when they're defined. And then we have a doLogin function that then assigns the arguments passed in when it's called to those variables. Does that make sense?
So that's how you break the scoping to get those values out?
Well, so the variables are defined in the top level of they're defined inside of the user function, and the doLogin has access to them because of the scoping,
right?
But it doesn't actually assign them; they're just defined.
But so why would you do this over, say, returning a whatever construct, like a map that has username and password in it, a hash that has username and password in it?
Well, I think because maps are a new thing to JavaScript.
Okay.
Like, I don't think maps have been around that long in the language.
Okay.
That's my understanding, but I am totally possibly wrong, and I'm totally open to having people go, don't know what the hell you're talking about. I know as much about JavaScript as this book and playing around on some quizzes has taught me, and I'm not all the way through this book.
So what's going on? A module is a function, and you create a variable in that function. What's going on in that login, do login thing? That's just is that a map? Yeah, that's a map.
Yeah.
So
yeah, the key login calls the do login function.
Okay.
Does that make sense?
Yeah, but
and the do login function takes two arguments, a username and a password. and then does something with them.
And you're calling that key by Fred.login.
So Fred equals the function user, and then Fred.login takes those. Apparently this is a common construct for modules.
Oh, okay. Because do login is that it takes a parameter of user and password.
Yeah. Public API is actually an object.
Yes. Or a hash. I'm not sure the difference.
It's not a hash. It's an object in this case. This is what an object. The key value pair inside of curly braces is an object in this language.
Okay.
That's what they call it.
So it's basically just setting it to an instance of an object. Okay.
Yep.
So this is going to return a...
I mean, I don't know. It's gonna return a public API.
Yeah. Okay. Whatever that is.
And, well, I mean, the user returns the public API, and then the login is going to do some kind of logic down inside of that do login function.
Okay. So potentially it would return. It's not listed in this code, but it might return like the user ID.
Right.
Okay.
So this is a thing you're going to see a lot in JavaScript. So if a function has a this reference inside of it, that this reference usually points to an object. But which object it points to depends on how the function is called. This does not refer to the function itself. We'll get to what we're going to go through the rules here in a second. But yeah, it's kind of like self in some other languages, but don't let it fool you. So here's an example of this. Function foo console.log this.bar. So var bar equals global, object 1 equals bar object 1, foo key equals the foo function, var object 2 equals bar key with the string object 2. And then if we call foo, we get global because the var bar is defined on the global level. If we call object 1.foo, we get object 1 because it calls bar at that scoping. If we call foo.call object 2, we get object 2 because foo.call passes in the scoping of bar for object 2. And if we call new foo, we get undefined because foo is not an object. It's a function.
That's kind of interesting. It's almost like the functions aren't really attached to anywhere in the code. They can move around.
Yep. So the this cares about the context in which it's called, or the function gets called. So if the function's called inside of an object, it gets the scoping of whatever it needs from that object, if it can. If it's called outside of an object, it gets the global scoping. If it gets called on an object, like with a .call method, then it gets the scoping of that object.
It seems like it could be really powerful, but also it could be kind of confusing.
Yep. I think if you internalize the rules of it, if you got to where you could learn. So here's the rules. Foo ends up setting this to the global object in a non-strict mode. In strict mode, this would be undefined. You'd get an error in accessing. So remember we talked about before the use strict. So in that case, it would go. I don't have a bar, but if you don't do it in classic, it uses the global. object.foo sets this to the object1, and then foo.call object2 sets this to the object2 object. And then new foo sets this to a brand new empty object. And since it's undefined, since it's a brand new empty object for which there is no bar yet.
So, I mean, I've tinkered a little with JavaScript, but I never really realized how integral objects and functions were to the language.
Yeah. And it's going to dig deep, the stuff that we've got. Now we're getting to prototypes, which is the supposed to be the thing that makes everybody not understand JavaScript because they want to treat it like classes, and it's not classes, it's prototypes. But prototypes are they're used to delegate behavior between different but linked objects, and they're not the same thing as class inheritance. Prototype inheritance is different. And then that's all it goes into really in detail in this chapter. It's a whole chapter on prototypes we'll get around to.
Okay.
Something that, so one of the reasons I said, you know, we have all this, I talked about ES6 code, which isn't even supported in all these browsers yet. Why would we even talk about ES6 rules if we can't use them in browsers? And that's because JavaScript has two ways to let us use them in browsers, called polyfilling and transpiling. They let you write ES6 code, but the code will still be used in the browsers that don't support ES6 by, so what polyfilling does is it says, like, you write, there's all these libraries for polyfilling that says, like, you write a function, and it says, like, if this browser supports this function, or supports this behavior, use the ES6 behavior, otherwise, use this thing that sort of tries to pretend to be the same thing. It does it in much more verbose and less fancy code.
Okay, and I read an HTML5 book that talked some about that.
Yeah,
I think
polyfilling is becoming less popular, I think, because transpiling is, I think, what a lot of people have gone to, which transpiling takes existing code, existing ES6 code, and converts it into older versions of JS that have wider browser support. So it actually converts the code into older JavaScript code. So yeah, it compiles the code and rewrites it as older JavaScript. And that is the end of our presentation.
That's interesting.
So I am going to drop the slide screen.
Okay. So I think one of the things that always got me about JavaScript was that it is in a browser, and browsers are so different. You have different versions, you have different vendors, and like I don't know how it is now, but I know that, you know, in the past there's been issues with compatibility between browsers and what they support. So I don't know if you guys know or not, but is that getting better? Is that still an issue? And how do you feel about, like, coding in a language that you don't really know if your user base even supports the code that you're trying to write?
So transpilers go a long way towards solving that problem.
Okay.
Not all the way, but they go a long way. Because what you do is you just insert checks that says, like, you know, if this is this kind of a browser or newer, run this block of code. Otherwise, run this block of code.
And it just converts it into an older version of the same function.
Mm-hmm.
Okay.
Yeah. Or, well, I think that actually may be polyfilling. Transpiling, it doesn't even do that. It just converts it into older code. Like
okay.
when it gets rendered to all the browsers, it's in the older version. And so, yeah, it doesn't even have to do those if checks. So I guess, yeah, that's right.
Okay.
But, I mean, that's just a function of dealing with JavaScript. You know what I mean?
Mm-hmm.
Like, the alternative is writing some other language and then compiling that into JavaScript. But even then, you're still going to be compiling. This lets you compile new JavaScript into older JavaScript instead of some other language into old JavaScript.
Right.
So.
Okay. That makes sense.
I don't know that you can get around that problem. I don't like it. But it's just a feature. So I actually am glad that ES6 and stuff like that is around, because when I started to read this book, I have no love for JavaScript as a language, but I have less disdain for it now than I had before reading a good chunk of this book, because ES6 solved a lot of the problems I had with the language.
So I thought this was good because it introduced me to some interesting features to JavaScript that I wasn't really aware of. Like, so I've seen jQuery and I've seen, your basic procedural stuff that I'm able to kind of cobble together because I've used another language. But I hadn't really seen some of the thing, like you said, with, the objects and the functions. You were going through some of the things that they do there with the this and the varying scope and context and stuff. That looks like, I'm not really sure what you do with that, but it seems like there's something that's kind of useful you could do with that.
There's power there waiting to be used.
Exactly.
Yeah, it's definitely. It's like you're looking at that going like, somebody wrote this for a reason. It looks like it's something that can be super useful.
Exactly.
Yeah. That's how I felt about it too. And so that, like we said, like this first section is literally just an overview of, this is what the book's going to cover. This is all very like 1,000 feet overview of the concepts in the book series. And so next week we'll get into a little deeper dive on like how some of so what is next week's book? We're going to do the first part of what? Scope and closures. Yeah.
I think I signed up for that, didn't I?
I think so. So we'll do chapters 1, 2, and 3 of that, right?
Yeah, that sounds good. I'll do that. Ooh, I get to do scope, closure, and this. All the things I was asking about.
Actually, hang on a second. Let me look at the scope. Pretty long. Lexical scope is pretty long. Function versus block scope is super long. Hoisting is short. And scope closures is long. So why don't we try to do what is scope and lexical scope?
Okay, so we're just 1 and 2.
And then I think we can do, and if you feel like up to it, you can go ahead and do the slides for 3 as well.
Okay.
But 1 and 2 is going to be a lot to cover.
Okay, sounds good.
Yeah, a lot of the questions you had will be the first things that it covers.
I'll get to answer them.
Yeah, and we actually covered lexical scope. We covered a lot of what it does, but this is going to go into how it works in pretty good detail. You know what? We can get through 1, 2, and 3. I'm looking at them. We can definitely do 1, 2, and 3. So yeah, let's do 1, 2, and 3.
Okay.
1's a little long, but it's just explaining scope. 2's pretty short.
Sounds good to me.
Awesome.
Yeah. Cool. All right, I think that's going to do it for us. Do you guys want to call it a night? We covered a lot. Do you have any questions about anything or stuff we want to discuss about the language, other than the way it deals with arrays is insane?
I probably should have a lot of questions, but I was just kind of sitting here taking it all in.
Yeah. Well, and all 3 of us have experience with other languages, so nothing that we covered tonight was completely foreign to us.
I'm kind of interested to see the differences between null, undefined, and not a number.
Well, so null is like nil.
Okay, it's just
And,
absolutely nothing. It's not a value.
yeah. Yes. Undefined is, so like for example, when you had var a
Mm-hmm.
and you hadn't assigned anything to it, it was still undefined. I think.
Okay, so it's almost like an empty memory reference, or
yes, yes, I think so. Let me see. Say var a. Yes. If you just do var a semicolon and then just call like a semicolon, it'll give you a as undefined.
Okay.
So yes, that's what it means. It means like it's not, or I think you can just, I think you could try to call an undefined variable, like if the variable even hasn't been declared, I think if you try to call a variable that hasn't been declared, it'll also return undefined, but it might return a no reference error. I'm not sure. I'd have to look. But yeah, it just means that the variable hasn't been defined yet.
Okay.
And then not a number means you called something that is expecting this to be a number and it's not. And I can't coerce it into a number.
Okay, and they need that because of the type coercion that's automatically happening to differentiate between different errors that might be going on there.
Yes. So another thing is one of those, null or undefined, is buggy. And if you try to call type of on it, let's see which one is it? Type of undefined. There we go. That's not going to work. Type of null? Yes. So if you call type of undefined, it gives you undefined. If you call type of null, it gives you object, which is a bug. But it's a bug that has been around so long, and so much JavaScript code depends on taking advantage of that bug that they don't fix it. Yeah. Yeah.
Okay.
It's no longer a bug, it's a feature.
So if you did, so null is truthy evaluated to false.
No, null is falsy. Undefined is falsy. But if you call type of on null, it's going to return object.
Truthy.
It's going to return object as its type.
Right.
So when it should return null as its type. And so there's actually code out there that takes advantage of the fact that null returns object when you call type of on it. And there's like tricks people use to like do like weird kind of checks for null versus undefined and stuff like that takes advantage of the fact that it'll return type of as object. Yeah. Yeah. And there's a lot of code out there that apparently that does that.
That's kind
of
crazy.
They don't dare fix the bug in the browsers.
So you said that strict does some stuff other than disallow globals. Was there anything that you saw mentioned that it does specifically other than that?
Let me see if I can remember. Let me look at the first book here. Up and going. Yeah, I can search this repository for use strict. Here we go. Oh, that's not going to work because not just searching the book, it's also searching the code associated with the book, which does use strict all over the place. Here we go. Strict mode. So ES5 added strict mode to the language, which tightens the rules for certain behaviors. Generally, the restrictions are seen as keeping the code to a safer and more appropriate set of guidelines. Also, adhering to strict mode makes your code generally more optimizable by the engine. Strict mode is a big win for code, and you should use it in all of your programs. You can opt in using this. One key difference / improvement with strict mode is disallowing the implicit auto-global variable declaration, which we discussed. If you turn on strict mode and you get errors or code starts behaving buggy, your temptation might be to avoid strict mode, but that instinct would be a bad idea. If strict mode causes issues in your program, almost certainly it's a sign that you have things in your program you should fix. Not only will it keep your code on a safer path, but it will make your code more optimizable. It also represents the future direction of the language. And then he'll have, he says, note, for more information about strict mode, see Chapter 5 of Types and Grammar.
Okay, so we'll get there.
Yeah. So, like I said, you know, thousands of you. But
cool.
Yeah, I'm feeling pretty. This book is like, I think this book is really pretty good. It doesn't like, I don't understand why everybody doesn't use this as like their second or third thing they read about JavaScript, because it does a really good job of explaining how the language works, especially if you have some background in programming already.
Cool.
So I'm looking forward to covering more of it. So,
yeah, definitely.
I think that's going to do for tonight. We've been going for a little over an hour, so.
All right. Well, I can go ahead and shut down the broadcast.
Cool. See you guys next week.
It was great seeing you guys.
You too.
Enjoyed the whole thing.